Okay, and welcome to my first presentation, and that will be index law number 1, which is commonly known as index multiplication. Now, as an example, let's look at multiplying 2 squared. We'll multiply that by 2 to the power of 3. So 2 squared, 2 by 2, is equal to 4. 2 to the power of 3, or 2 by 2 by 2 is equal to 8. Now, I can write this as an index with a base and an index. The base will be 2, and the index will be 5. Why is it 5? Because I have 1, 2, 3, 4, 5 2's here. And if I basically work out 4 multiplied by 8, I will end up with, okay, well, 32. So we can say 4 multiplied by 8 is 32, or 2 to the power of 5 is 32. Now this is just a very simple example, but this is true for all situations. So index law number 1 states a to the power of m multiplied by a to the power of n equals a to the power of m plus n. So whenever you're looking to apply this law, always look to see whether you have the same base. Now I'm going to move to the next slide, and by means of a couple of examples, this should all start to become a little bit clearer. So first situation here, I have a base of 7 over here, base of 7 over here. So I can say that my base, when I multiply these together, will become 7, and my index over here is 3, and my index here is 8, so I will look to add these up. 3 plus 8, and that becomes 7 to the power of 11. Okay, let's move on to our next example. Now, our next example, just getting the hang of this now, is let's look at c squared multiplied by c to the power of 5. Now, in this situation here, c is some unknown number. Now, do we have the same base? Yes, we do. That base is c. Now, we have a c squared and a c to the power of 5. I will add those because I am multiplying c squared by c to the power of 5, and the answer will become c to the power of 7. Okay, so let's clear that one, and we will move on to our next example. Now, this one here, slightly trickier. Now, when you have an x or any number by itself, you can consider that to be raised to the power of 1. So, if I rewrite this, this would become x to the power of 1 times x squared. Now, I think we'd be able to work that one out. That becomes x to the power of 1 plus 2, which becomes x to the power of 3. Just remember, if you see any number by itself, you can consider it being raised to the power of 1, or any base by itself, consider that to be raised to the power of 1. Now, I will now move on to the next one. I'll clear those annotations and get rid of that one. I'll make this slightly more complicated. Now, in this situation here, I have 2 different bases, an x and a y, and over here another x and another y. I need to treat the x's, the base of x, separately first. So I have x, now I have an index of 2 and an index of 5, so I can write this as 2 plus 5, and then let's look at my y base. And I have an index over here of 3 and another index of 3, so this becomes 3 plus 3, so I can simplify this to be x to the power of 7, y to the power of 6. Okay. I'll move to the next one, clear those annotations, and this is the last one that we're going through, which again, just a little bit more complicated. So with the 3 and the 4, we call those coefficients. Now, we can just multiply those numbers straight out. So 3 multiplied by 4. So we'll just deal with the coefficients first. Now, I have my x's. This x will be x to the power of 1. So it becomes x to the power of 1, and we treat the x over here with the 2. So I'll add 2 to that one, plus 2, and then I look at the y's. Now, you can see here I have y squared, y to the power of 10, that becomes 2 plus 10, and then I can do a little bit of simplification. 3 multiplied by 4 is 12. Now look at my base x. It has an index of 1 plus 2, which is 3, and my y has an index of 2 plus 10, which is 12. So that is my last example. Let's just go back to the previous slide here and just look at this index law number 1 again. A to the power of m multiplied by a to the power of n equals a to the power of m plus n. So always just double check you're using the same value for the base. So hopefully this has assisted you.